Good morning, everyone. My name is Muhammad Khairul Amin bin AZIZAN, and the matrix number 1910923333 from Group 2. For today, I will present about my project report for the subject EET 208 Electrical Power Technology. The title is Three-Phase System. My lecturer name is Dr. Shahrul Nizam bin Muhammad Arshad Elias Hashim. Introduction. The system which has three phases, which is the current will pass through the three wires, and there will be one neutral wire for passing the fault current to the earth, is known as the three-phase system. In other words, the system which use three-phase wire for generation, transmission and distribution is known as the three-phase system. The three-phase system is also used as a single-phase system if one of their phase and the neutral wire is taken out from it. The sum of the line currents in the three-phase system is equal to 0, and their phases are differentiated at an angle of 120 degrees. The three-phase system has a 4-wire, which is the 3 wires are carrying current through the conductor and the 1 wire are connected to the neutral. The cross-section area of the neutral conductor is half of the live wire. The current in the neutral wire is equal to the sum of the line current of the 3 wires and consequently equal to square root 3 times the 0 phase sequence components of current. The three-phase system has a several advantages, like it requires fewer conductors as compared to the single-phase system. It also gives the continuous supply to the load. The three-phase system has a higher efficiency and minimum losses. The three-phase system induced in the generator, which gives the three-phase voltage of equal magnitude and frequency. It provides an uninterruptible power, which means if one phase of the system is disturbed, then the remaining 2 phases of the system continuous supplies the power. The magnitude of the current in one phase is equal to the sum of the current in the other phase of the system. In three-phase circuit, connections are given in 2 types. 1. Star connection and 2. Delta connection. In star connection, there is 4 wires. 3 wires are phase wire and 4 is a neutral, which is taken for the star point. Star connection is preferred for long distance power transmission because it is having the neutral point. In this, we need to come to the concept of balanced and unbalanced current in power system. The star connection can be shown below as in the picture. In star connection, the line voltage is square root 3 times of the phase voltage, and the line current is the same as a phase current. It is shown as expression below. E line equal to square root 3 E phase, and 2 I line equal to I phase. In delta connection, there is 3 wire alone and no neutral turbine is taken. Normally, delta connection is preferred for a short distance due to the problem of unbalanced current in the circuit. The figure is shown below for delta connection. In the load station, ground can be used as a neutral part if required. The delta connection can be shown below in the picture. In delta connection, the line voltage is the same as the phase voltage and the line current is square root 3 times of phase current. It is shown as expression below. E line equal to E phase, I line equal to square root 3 I phase. Lastly, 3-phase circuit that are star and delta connection can be arranged in 4 different ways. Star to star connection, star to delta connection, delta to star connection, and the last one is delta to delta connection. For this project, I use the PSIM software to design a circuit and get the result. PSIM is an electronic circuit simulation software package designed specifically for use in power electronic and motor drive simulation, but can be used to simulate any electronic circuit. The objective for my project is evaluate The parameter of the electrical system in the context of transmission and load impedance are given based on the metric card number, current voltage and acceptable voltage drop based on BS 7671 or any Malaysian authority standard. To evaluate and analyze the active power absorbed by the loads by using 2 wattmeter and the conventional measuring method. And 3. Identify the normal operating condition of the electrical system and validate the study with the simulation using PSIM software. Methodology. Data collection. In this project, the data that I have collected is from PSIM. The version that I have used is PSIM 12.0.4. PSIM is one of the software that we can simulate the circuit that we draw and put the value that we want. From that, we can get the value and graph clearly. The resistance and reactance of the loads are given according to matrix number, that is 19109233. Okay, as we can see in the picture, for my matrix number, we can get the data for transmission loss and for load. From the word, I simply keep in to the PSIM and estimate of V line is 132 kilovolt. I have to change the incentive agreeing for the words given after completion of the circuit. I have to run the recreation and get the word each part, and the reactance will show the unit. Ultimately, I have to spare and compress the record and recreation. I also prefer the circuit based on the slide that given to us. Okay, we can see that I have two pictures. For the left side is I need to convert to PSIM based on the circuit. For the right side, this is the circuit that built in the PSIM software. Method of analysis. The method that I use to analysis is theory calculation. First, I use the formula star to star connection. The formula is, as we can see in the slide, phase voltage in phasor and the line voltage in phasor. For the phase voltage, EAN, EBN, ECN, and the line voltage, EAB, EBC, ECA. As we can see the same, between the phase voltage and the line voltage is a angle, which is for the first one 0 degree, and the second one is negative 120 degree, and the third one is 120 degree. Okay, the formula for I line equal to volt over Z line plus over Z load. Formula for voltage phase load, V phase line equal to I phase line multiply Z phase line. Formula for V line load equal to square root 3 multiplied by V phase line. Formula for voltage phase, VAN, VBN, VCN, as we can see in the slide. Formula for I phase, current phase, IAB equal to VAB over Z total. After get the value of calculation, I compare with the result from the simulation. Okay, this is the result that I get from the PSIM software. As we can see, voltage line to line primary, voltage line to line secondary, line voltage to neutral primary, and the line voltage to neutral secondary. Okay, as we can see in the result, V1, V2, V3. And then V total is a V has V total V1, V2, V3. This is the circuit that I designed in the PSIM software. Okay, for the formula is V line equal to square root 3 V phase. V line that I get is 132 kilovolt. So I insert the formula to get the V phase. For the omega equal to 2 pi F. F is a frequency, that is 50 Hz. Then we get the omega. For the inductors, ZL equal to J omega L. So from this formula, omega we get And the ZL also we get that given to me is 9J and 23J. And then we insert the formula for inductor to get a real value. For I like equal to I face. For this one, I get the result from the simulation in the PCM software for current I1, I2, I3, I4, I5 and I6. We can say that I-line equal to I phase. Okay, from the calculation, we must apply the formula, which is V drop equal to V supply minus V load over V supply multiply 100%. As we get V line equal to square root 3 V phase. V phase we get N. We apply into the formula. And then we also must find 2 wattmeter method. As we can see in the slide, the formula. Discussion. In this lab, I use a PCM software to complete this project. Firstly, I must calculate the inductor value for formula ZL equal to J omega L. I have to convert all the impedance to inductor value. I have to convert 33J to 0.0732 Henry and 9J to 0.0289 Henry. I have to convert it because in simulation it does not support the impedance unit. After that, I draw the circuit in PCM software. The circuit that I have drawn is star to star connection. Next is set the value of voltage to 76.2102 kV and using a frequency 50 Hz. I use this value because the value that given in the table is voltage line equal to 132 kV. Using the formula V line equal to square root 3 V phase, I get the phase voltage of the circuit. Phase voltage equal to voltage supply. I also have to plot the probe to get the output. Moreover, I need to run the simulation to get the data. Next, I also have to make a calculation based on the circuit. Then, I need to compare the measure value and the calculation value to get the same. It should get the same value because the calculation and the practical is same. Finally, I also find the voltage drop percentage. And the conclusion, I can conclude that I have learned the way to use PC software. After that, evaluate the parameter of the electrical system in the context of transmission and loss impedance based on a matrix number, currents, voltage and acceptable voltage drop based on the BS7671 or any Malaysian authority standard. Moreover, evaluate then analyze the active power absorbed by the loads by using 2 wattmeter method and the conventional measuring method. Finally, the normal operating condition of the electrical system and validate the study with simulation. Okay, for the last one, reference. Okay, this website that I refer to do my project report. That's all from me, so thank you.